Okay, so based on what we saw with on Desmos, let's start with the square root of 16. Okay, and another way to write that is actually normally we don't include it, but this time I am going to write this. These are equivalent; they mean the same thing, and we just found out that we could write this as an exponent as I'll use parentheses 16 to the 1/2 power. Okay, and then what number squared gives me 16? 4. So I can also write it this way: 4 to the second power. Instead of 16, I wrote it this way, and that's to the 1/2. All right. And now we're going to use a rule. Okay, here's a rule that we used before. What do I do with the 2 and the 1/2? I have this power raised to that power. What do I do with the 2 and the 1/2? Multiply them, yeah. Whenever you have a power to a power, you multiply. So basically, this is 4, and then I would write this in red, 2 times 1/2. And this is just to prove to you that this works. These rational exponents work. We call them nth roots. What's 2 times 1/2? 1. So this is really 4 to the 1, which equals 4. And what's the square root of 16? 4. I know, we're never going to do this again. I mean, I would never recommend doing all of this to get the answer 4. But the purpose of this whole thing right now is to show you this is the same as that. They're consistent. Mathematically, they work. And a lot of times, you're not going to want to use a root this way. You're going to want to think of it as a power, as an exponent. Okay? So you could do it with anything, any type of root that works, this whole long experiment. So let's get in and write down what an nth root is. I'll use a different color. So here's the official definition and all that extra stuff we just learned about. Okay, the nth root is if you have some root like this, the nth root of a, and n is any integer, then you could rewrite it this way: a to the 1 over n. Okay? Write that down. That's a big one. So now we don't have to use that radical symbol. Remember we called that the radical symbol? We could just throw it out if we need to. Um, so let's write down some important guidelines for this. Okay? So, and these are things we were just talking about, by the way. If n is odd, so if this number or that number is an odd number, you have one real root. So you have only one answer. Um, if n is even, you have two real roots. Oh, by the way, the actual root that you have is a to the 1 over n, whatever answer you get, just that answer. You have two real roots. And that's going to be positive or negative. Remember that plus minus symbol we played around with last year? So all this is saying is if you have answers when it's even, you have two answers, the positive and the negative. Because remember, for square roots, 6 times 6 is 36, and negative 6 times negative 6 is 36. That's why you have both of them. And that works for all even ones. So if this is 4, 8, 20, 100, the 100th root, you still have just two answers. If it's an odd one, you only have one answer. Okay? Just either the positive or the negative. Okay. Now, here's another one. The nth root of 0 equals the a to the 1 over n. And what does that all equal? 0. So the nth root of 0 is just 0. Square root of 2, square root of 0 is 0. Cube root of something is of 0 is 0. The 100th root of 0 is 0. Okay. All right. Next one. We have two more. This one and another one. If n is even again, and a, meaning this a, is negative, okay, so this is even, square root, fourth root, sixth root, etc. And this number inside is negative, then n to the cube root of a, which is negative, and that's even, equals a to the 1 over n is not a real number. That's why, the square root of negative 4 is not a real number. The eighth root of negative 4 is not a real number. Okay? Okay. So go ahead and write that down. And we're going to practice a little bit with this, okay? So we're just going to simplify. Oops, wrong pen. Okay. Number 1. Cube root of eighth root, of negative 20. Write that as a rational exponent, meaning something like this. How would we write it? It's looking like this now. We want it to look like this. I'll put parentheses in negative 8. What's the exponent going to be? Well, look, it's my n is 8. So how would I write it over here? Oh, I messed up though. I see why you're looking confused. I apologize. I should have a negative 20 in there, right? That's better. Okay. It should be this way. Now, what kind of number is 8? Odd or even? So what's my answer here? Okay. Okay. Let's try this one. 2 cube root of negative 125. So first convert it to rational exponent. How's that going to look? Negative 125 to the 1/3. Okay. And now, what number times itself 3 times equals negative 125? Would you agree? Negative 5 times negative 5 times. So I'm going to write it this way. Negative 5. Oops, actually I want 2 parentheses. I just thought about that. To the 1/3. Okay. Oh, I need a 3 here. So it's negative 5 to the 3rd. That's actually negative 125. Okay. So now remember we're allowed to multiply these. 3 times 1/3. So this is negative 5 to the 3 times 1/3. And what's 3 times 1/3? 1. If you want, you can cross cancel and show this is just negative 5 to the 1, which is just negative 5. Okay. Again, we're just showing how that works. Okay. Now, this one's going to lead to a new discovery. Let's try this. The 5th root of x to the 30th. Okay. Go ahead and write that down. The 5th root of x to the 30th. So we're just going to do kind of what we did here. I'm going to say x to the 30th raised to the what power? Remember, you use this as your denominator. This is your denominator to the 1/5 power. Okay. And now, what can I do with this 30 and the 1/5? Multiply them. So this is going to be, and this is one of the reasons we do this. Okay, this is going to be x to the 30 times, 30 times 1/5. That's 30 times 1/5. I'll do one extra step. This is x to the 30 over 5, right? 30 times 1 is 30, and then 5 is your denominator. You could simplify that. Yeah. All of this simplifies down to x to the 6th. Okay. Now, what I want to highlight for you was that this right here, it became this. So this is going to give us a shortcut, guys. So we have the index here, right? That's our denominator. What did this 30 become? The 5 became the denominator here. What did the 30 become? Numerator. So that brings a new rule. We only got 2 rules, so don't think, oh my God, how many rules are there going to be? We got this one, just the nth root. And we have this one. Okay, so this one is the nth root of a to the m power is the same as a to the m over nth power. Okay, so this is another rule, or the other rule that we're going to be using. And let's highlight a couple of things. The numerator, in this case, it became m, so is the power of the base and that was n. So it was the base number was a, right? And the power was m actually. And that was m. Denominator so the denominator is the root n. Okay. So we're just going to be doing this conversion from time to time. Okay. All right. So let's go ahead and do just a couple more. So what we're mainly going to be focusing on is stuff like this. I guess this is number 4. Let's say we have, this is number 4. The square root of 121 x to the 8th. Okay, we have 121 x to the 8th. Go ahead and write that down. Now, what number squared is 121? 11, right? 11 times 11 is, okay. So what we're going to do is we're going to do this. We have 11 squared times x to the 8th, right? And we're going to raise that to the 1/2. So I have 11 squared and then x to the 8th. Everyone see how I got all that? Instead of having the square root symbol, I'm using this 1/2 to the 1/2 power. Okay, now we're going to distribute. we're going to share that. Okay, so this becomes 11 squared to the 1/2 and x to the 8th to the 1/2. Okay, so this becomes this. All I did was share that 1/2 power. So what's 11 squared times 1/2? What's 2 times 1/2? 1. So this really becomes to the 1 power. It's 11 to the 1. I'll write that temporarily. What's 8 times 1/2? 4. So I don't need that 1 power. Like I said, that's only temporary. So if you can catch it here, you could say 2 times 1/2 is 1. 11 to the 1 is just 11. So my answer is 11x to the 4th. Okay? Let's practice another one. Let's do the cube roots of negative 125 x to the 28th. Okay, we're going to follow the same process. Okay, let's put this under 1. Negative 125, I put that in parentheses. Oh, wait a minute. What number times itself 3 times? I should do that. What number should go in here? Well, negative 5. But yeah. Negative 5 to the 3rd power. Okay. And then we're going to multiply that times x to the 28th. And then what goes out here? Now we have to deal with this. 1/3. Okay. Square root, it was 1/2. Cube root, it was 1/3. Okay. Now we're going to share again. Okay. So now share that 1/3 power to each of these. So I got negative 5 cubed to the 8th power. 1/3 power. So this to the 1/3 power times x to the 28th to the 1/3 power. So what's going to happen with 3 times 1/3? It's going to be 1. It's going to happen over and over again. This is just 1. So really we're just going to get the negative 5. What's 28 times 1/3? It's the same as 28 divided by 3. I'll let you figure that out. Negative 5 to the 1 power is what? What's negative 5 to the 1 power? Negative 5. What's x to the 28th times 1/3? 28 over 3, which simplifies down to what? Yeah. And sometimes it's just going to be like that. Negative 5, x to the 28 thirds. Let's get one that does simplify, and then we'll call it. Okay? This will be the last one. Okay. cube root of 8 x to the 24th. Okay, so we have 5. I'm sorry. What number times itself 3 times is 8? So we have 2 to the third, and then we have x to the 24th, all to the 1/3 power. And then let's go ahead and share that. So this becomes 2 to the, if I multiply it, I get 3/3. I'll show it to you this way. Maybe that'll make more sense. 3 times 1/3 is 3/3, right? And then we have x to the 24 over 3, right? 24 times 1/3. Let's simplify those. 2 to the 3 over 3 is 2 to the 1, which is 2. What's 24/3? X to the 8. And that's our answer, 2x to the 8th. Okay. We're going to practice 2 of these on delta.